The most beautiful thing we can experience is the mysterious. It's the source of all true art and science.
Hmm. That's Albert Einstein, of course, a mind that really, really wrestled with the big stuff.
Absolutely. And today we're diving into one of those mysteries he himself initially found tricky, the expanding universe.
Welcome to the deep dive. Yeah, we're
Yeah.
tackling that very concept. We've got a great source here that helps unpack what this, well, frankly, mind-bending reality actually means. Why it feels so weird compared to, everyday life.
And how scientists even figured it out. Our mission, really, is to pull out the key ideas from this material, the history, the physics, the sheer strangeness of it all.
We want to help you get your head around this fundamental concept. It's pretty crucial stuff.
Definitely. Whether you're maybe studying for exams like the UPSC mains or prelims, or you're just fundamentally curious about, well, everything. This is a big one.
Okay, let's dive in then, because the picture our source paints, it's way stranger than just thinking things are flying apart from some central point like cosmic shrapnel. Oh yeah, forget the simple explosion idea. That's not quite it.
The really challenging bit, the thing that kind of breaks our brains, is that the actual fabric of space is stretching everywhere, all at once.
And then there's the kicker. Because of this, there's no single center to the universe. It looks like everything's moving away from you no matter where you happen to be.
That's wild. That idea, no center, and space itself doing the expanding. That's the core concept, right? The one that's hard to grasp, but so important.
Exactly. Our source really guides us through that. It's not like galaxies are, speeding through some static cosmic arena. The arena itself is getting bigger, and it's carrying the galaxies with it.
So it's the space between things that's actually growing.
Okay.
Okay. How did we even arrive at this understanding? Because for a good while, the thinking was totally different.
Completely different. Yeah, let's roll back maybe a century or so. Think 1910s, Einstein's general revolutionary stuff about gravity, space-time was the new big theory.
Right. Hugely influential.
But the general assumption then, even by Einstein at first, was that the universe overall was static, fixed, unchanging in size, like a permanent stage.
It feels more intuitive somehow. Stable. Predictable on that grand scale.
It does. But then astronomers started looking farther out with better telescopes, and they saw something odd.
With distant galaxies.
Exactly. Especially the distant ones. They weren't just sitting still. They looked like they were moving away from us. And the really strange part, the farther away a galaxy was, the faster it seemed to be moving away.
Which is, well, the exact opposite of a static universe. It's like the cosmos itself was saying, guys, about that static idea.
Precisely. It created a real headache. How does this amazing theory, general relativity, account for observations that suggest everything's flying apart?
And what's so cool, as our source points out, is that they didn't actually have to throw out Einstein's theory. The math, the framework itself, was more flexible than they maybe first thought.
Right. It turned out that GR could describe a static universe, but only under very specific, maybe even contrived conditions. But it didn't demand it.
So it allowed for other possibilities.
Exactly. Scientists looked at Einstein's equations again and realized, wait a minute, these equations work perfectly fine, maybe even better, for a universe that's dynamic, evolving, expanding.
So the math actually supported the observations.
Beautifully. Models where space itself was expanding just popped out of the mathematics of general relativity. Suddenly, the theory and the observations clicked. The universe wasn't static. It was growing.
And the author of our source, who teaches this, really emphasizes how counterintuitive this is for us.
Oh, absolutely. Our brains evolved dealing with objects moving within space, right? Not space itself stretching or moving.
Yeah, picturing expansion without a center or space just growing,
Yeah.
it clashes with our basic gut feeling about how the world works.
Which brings us right back to that fundamental question. What does expansion really mean in this context? Because it's not like, say, blowing up a party balloon inside a room.
Right. The room isn't getting bigger, just the balloon. But that's not the universe analogy.
No. Our source explains it well. When cosmologists talk about the universe expanding, they mean the actual distance between any two widely separated points in space is increasing over time. Think of, like, stretching a huge rubber sheet. Points drawn on the sheet just get farther apart as you stretch it.
Okay, so the observation is distant galaxies look like they're moving away, faster if they're farther.
Yes, that's what we see. But the interpretation, the deeper understanding, isn't that they're all just blasting away through space like rockets launched from here.
It's the space between us and them that's doing the work, stretching and increasing the distance.
Exactly. Which is why that common fireworks analogy for the Big Bang, well, it kind of misses the mark, as our source points out.
Yeah, talk about that. Why is the fireworks picture misleading?
Well, two main reasons, really. First, fireworks explode from a single point, right? So that analogy makes you think the universe's expansion started from one specific spot, a center.
Which we've already said isn't the case.
Precisely. And second, it makes you think the galaxies are like bits of shrapnel flying outwards through pre-existing empty space. Again, focusing on the motion of the objects, not the change in the space itself.
Got it. So it gives the wrong impression about both the center and the movement.
Yeah. The reality is, well, it's weirder and more profound. It's not stuff moving across space from a center point. It's the space itself growing everywhere, increasing the distance between everything.
Okay. So if the fireworks analogy is out, what about the balloon one? That seems more popular in explanations. Does that get closer?
It does get closer. It's a better step, though still imperfect, as our source is careful to note. Imagine you have a balloon, maybe draw some dots on its surface when it's deflated. Those dots are like galaxies.
Okay.
Now you inflate the balloon, the surface stretches, right?
Yeah, and the dots get farther apart from each other.
Exactly. And crucially, the dots themselves aren't like crawling across the rubber. They're stuck to the surface.
Ah, so they're carried along by the stretching surface.
Precisely. The balloon's expanding surface represents the expanding fabric of space. The dots are the galaxies being carried along. It illustrates nicely that it's the space between the dots growing.
That helps visualize the space stretching part, definitely. But you said it's imperfect. Our source mentions limitations here, especially regarding the no-center idea.
Right. This is key. Think about the balloon itself. It's a 3D object, right? It has the 2D surface, but also a 3D interior filled with air.
Yeah, the inside.
In the analogy, the 2D surface is what represents our universe's space, but that 3D interior, the air-filled part inside the balloon.
Where we'd normally think the center of the balloon is.
Exactly, that interior volume. It has no counterpart in the analogy for the universe. We're only using the surface.
Ah, I get it. So the analogy breaks down if you try to think about the inside of the balloon.
Precisely. And think about just the surface itself. If you're an imaginary 2D creature living on that balloon surface, is there any single point on the surface that's the center?
No. You could travel forever on the surface and never find an edge or a special central point you started from.
Yeah.
Every point looks kind of the same.
Exactly. Because the surface itself doesn't have an intrinsic center on it. And since the surface is the universe in this analogy...
Then the universe, in this model, doesn't have a center either.
Yeah.
Okay.
It's not that the center exists and we just can't point to it. The very structure, like the balloon surface, doesn't possess one.
That still feels deeply weird. How can something so enormous, the entire universe, not have a middle?
And that's where our intuition hits a wall. Our source brings up dimensions here. The balloon analogy uses a 2D surface living in our familiar 3D space. We think in 3 spatial dimensions: length, width, height.
Yeah.
But general relativity tells us the universe isn't just 3D, it's 4-dimensional.
4? Wait, you mean adding time?
Exactly. Time. Our brains naturally separate space and time, don't they? Like space is the stage, time is the clock ticking alongside it.
Yeah, that's how it feels.
But relativity smashed that idea. It showed space and time are fundamentally interwoven. They form a single 4-dimensional continuum called space-time.
Okay, so the expansion isn't just space stretching in 3D. It's this whole 4D space-time fabric that's expanding.
That's the picture, yes. And when you start thinking in terms of this unified dynamic space-time, concepts like expansion without a center become, well, less impossible. They're consequences of this deeper interwoven reality.
Our intuition, built on 3D space and separate time, just isn't built for that.
It really isn't. It's like trying to imagine a 4D shape when we can only perceive 3 dimensions. You can describe it mathematically, understand its properties, but truly visualizing it is incredibly difficult, maybe impossible.
So we rely on the math and the analogies, even if they're imperfect.
And the observations, of course. And our source makes it clear. Even grasping the expansion and the no-center idea, well, that doesn't solve everything.
Right. There are still big mysteries.
Huge ones. Like, what's actually driving this expansion? Especially the fact that it seems to be speeding up, accelerating. What energy or force is behind that? That's a massive area of research, things like dark energy.
Another deep dive for another day, maybe. But just confronting this idea, the expanding centerless universe in 4D spacetime, it really highlights the limits of just relying on gut feeling when it comes to the cosmos.
It absolutely does. It forces us to trust the evidence, the physics, the math, even when it leads to conclusions that feel bizarre. Everything expanding everywhere all at once.
It gives you a glimpse, doesn't it? Just how incredibly strange and, yeah, beautiful the universe we live in actually is.
It really does. And for anyone wanting to understand modern science, cosmology, or maybe tackling those big questions in, say, the UPSC exams, getting this concept down, the shift from static to dynamic, the meaning of expansion, the absence of a center, it's absolutely foundational.
It's a cornerstone of how we understand our place in the cosmos. So let me ask you listening. Thinking about this, the universe without a middle point, where space itself is growing between you and distant stars, how does that challenge your picture of reality?
Yeah.
It definitely makes me pause.
It's the kind of thinking that stretches the mind, isn't it? Which is essential for learning, whether it's for exams or just for the sake of understanding more about, well, everything.
Agreed. And maybe a final thought to chew on, drawing from our source. If space and time really are this single interwoven fabric that's actively expanding, what does that truly imply about the fundamental nature of reality? And what could possibly be the ultimate source of that relentless cosmic growth?
Big questions, the kind that keep scientists exploring.
We really hope this deep dive has helped shed some light on the expanding universe for you. It's a challenging but fascinating topic.
Yeah, absolutely. If you found this useful or just interesting, maybe give this deep dive a like.
And definitely subscribe to the deep dive on whatever platform you use.
We'd genuinely love to hear from you too. Any questions about this? Thoughts or, ideas for other big topics you'd like us to tackle? Drop a comment below.
Yeah, your engagement really does help us figure out what to dig into next. Thanks for joining us on the deep dive.